Hi all, I am Dr. Priscilla Jane S., Professor in Mathematics, working in Emmanuel Arasar JJ College of Engineering. Today we'll be discussing the topics irrotational vectors and solenoidal vectors. So before getting into the topic, we need to learn some definitions. The first definition, vector differential operator. The vector differential operator del is denoted by del equal I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z, where I vector, j vector, k vector are unit vectors along the three rectangular axes OX, OY and OZ respectively. Del is also known as the Hamiltonian operator. The next definition, divergence of a vector function. If f vector is a continuously differentiable vector point function in a given region of space, then the divergence of f vector is defined by divergence f vector equal to del dot f vector, that is equal to I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z, which is del dot f1 I vector plus f2 j vector plus f3 k vector, which is for f vector. So the dot product will give the result dou f1 by dou x plus dou f2 by dou y and dou f3 by dou z. So this is the definition for divergence of a vector function. The next definition is solenoidal vector. A vector f is said to be a solenoidal if divergence f vector equal to 0. That is, a vector f is said to be solenoidal if del dot f vector equal to 0. The next is curl of a vector function. If f vector is a differentiable vector point function defined at each point x, y, z in some region of space, then the curl of f vector is defined by curl f, that is del cross f. So curl f is nothing but del cross f equal to determinant I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3, where f vector equal f1 I vector plus f2 j vector plus f3 k vector. Irrotational vector. A vector f is said to be irrotational if curl f is equal to 0. That is, del cross f is equal to 0. If now the first example is if r vector equal xi vector plus yj vector plus zk vector, then prove that r vector is irrotational. Here we have to prove that r vector is irrotational. So the condition for proving r vector is irrotational is curl r vector equal to del cross r vector equal to 0 vector. So curl r vector, we'll be finding the curl of r vector, that is del cross r vector is determinant I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, and here we can see that r vector is xi vector plus yj vector plus zk vector. So the last row will be x, y and z. So now we'll expand the determinant so that we'll be getting I vector into dou by dou y of z minus dou by dou z of y minus j vector into dou by dou x of z minus dou by dou z of x plus k vector into dou by dou x of y minus dou by dou y of x. So here we can see that dou by dou y of z is 0 because partially differentiating z with respect to y is 0, and also partially differentiating y with respect to z is also 0. So I vector into 0 minus j vector into Here also we can see that partially differentiating z with respect to x gives us 0 minus again partially differentiating x with respect to z gives 0. So we'll get here like minus j vector into 0. Likewise, k vector into 0. So altogether we get 0 vector. So our condition for irrotational is satisfied. We get curl R is equal to 0. So the vector R is irrotational. Now example 2, show that the vector f vector equal 3y power 4 z square I vector plus 4x cube z square j vector minus 3x square y square k vector is solenoidal. Now we know the condition for solenoidal. That is, to prove a vector is solenoidal, we have to show that del dot the vector is equal to 0. So del dot f vector. So we know that del is I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z dot the given vector is f vector. So when we take the dot product, I dot I is 1, j dot j is 1, k dot k also gives us 1, but I vector dot j vector is 0, I vector dot k vector is 0, j vector dot I vector will give 0, and j vector k dot k vector is 0 likewise. Now when we take the dot product, I already told you I vector dot I vector gives 1. So when we take the dot product between the first terms in the brackets, we'll get dou by dou x of 3y power 4 z square plus then the second terms inside each bracket, dou by dou y into 4x cube z square, then plus dou by dou z of minus 3x square y square. Other all terms will become 0. Now dou by dou x of 3y power 4 z square, there is no x terms. We are partially differentiating with respect to x, so the result is 0. Same way when we come to the second term, there is no y term, so when we partially differentiate 4x cube z square with respect to y, we get 0. And the third term also, dou by dou z of minus 3x square y square is 0. So the result is 0. So we are getting del dot f vector is 0. So therefore f vector is solenoidal. I hope you all enjoyed. Thank you.